Hello students, I am Dr. Jagan Mohan from IARE. So, we have been discussing about the power system protection subject, and we have discussed about the circuit breakers, why the fault occurs in a circuit breaker, what is the necessity of the circuit breaker, what is the purpose of the circuit breaker, and types of the circuit breaker, and how the circuit breaker operates. And in our previous class, we have discussed about the SF6 sulfur hexafluoride circuit breaker. So many circuit breakers we have discussed, and in our previous class, we have discussed about the sulfur hexafluoride circuit breaker. So, the main thing here in the sulfur hexafluoride circuit breaker is that it is electronegative. So that means it attracts the free electrons. That means, so indirectly it is able to stop the arc as early as possible. So we have discussed about the air circuit breaker, oil circuit breaker. So one is greater than the next, and like that we have come. And this SF6 is better when compared to the previous circuit breakers in its own way, because it is very fast. Okay. So since it is electronegative in nature, it attracts. So if the electrons released or absorbed by this SF6, so automatically the short circuit will be closed as early as possible. So here the free electrons produced during the arcing are quickly absorbed. So because it is in the electronegative in nature. So without electrons, the arc cannot conduct, the arc cannot exist. So that's why this is the specialty in the SF6. So it will be having almost all as the same construction, almost the same construction as that of the remaining circuit breakers. So here also there will be a moving circuit, moving contact and a fixed contact. So like that, here also there will be moving contact and fixed contact, and whenever the contacts are open, so because there will be some ions, and because of this the arc exists. So immediately the arc cannot be extinguished. So it will take time. So how much fast we are going to extinguish this or matters. Okay. So for that only, so for the best performance only, we are searching, and we are going constantly for different types of alternate. We are searching for the alternates. We are always trying for the betterment. So best performance. We need best than this, like that. We are doing. So since the sulfur hexafluoride is electronegative in nature, this is having the best performance, since it attracts, it absorbs the electrons, so it stops the conducting, and immediately, indirectly, it will extinguish the arc as early as possible. So this is the diagram of this circuit breaker, and it is almost similar. So it will be having a chamber, it will be having a fixed contact, moving contact, and SF6 is sent into the chamber. So obviously it is having the, what is the advantage means? First advantage is it is having the superior arc extinguish property. So than all the previous circuit breakers. So it can interrupt large currents. So normally some, maybe the air or oil circuit breaker cannot, they can interrupt the arc to a certain level, to a certain capacity, but this is having, this can interrupt large currents. So the dielectric strength is more when compared to the other mediums. So that is 3 times. The dielectric strength is 3 times greater than the A. So it is performing better. So if the dielectric strength is more itself, the chance of occurring the arc is itself less. Even though if you are, even then we are going for very high transmission, high power transmission. So the arc exists. The arc will strike. So this dielectric strength is even useful in reducing. One side it is having more dielectric strength, and other side it is electronegative. So to best advantage it is having when it is compared with the previous circuit breakers. So and also it is noise free, and there is no need for exhaust into the atmosphere, and it is moisture free. So it requires very low maintenance. It also requires very low maintenance. So it is suitable for hazardous and hostile conduction like coal mines, and breakers are enclosed and sealed. So if you go for coal mines, so the environment is dangerous. It is hazardous. So if any small fire accident occurs in the coal mines, the gas, a methane gas is leaked there, and it explodes. So in such cases, we can use this circuit breaker, so which is having more advantages, and that's why we are going to use these things in the coal mines. So the disadvantage is the sulfur hexafluoride is very costly, and also we have to again recondition. The second disadvantage here is we have to recondition. The first thing is we want to, in the power system, sometimes the fault occurs. The fault itself means it is heavy current is flowing. The fault itself means the heavy current is flowing. So in the conditions we have to break the circuit. So even though we are able to break, so for the breaking purpose only we are having two contacts, fixed contact and movable contact. So the movable contact will move away from the fixed contact to stop the power transmission. But already since the fall it is very fast, already before we are able to separate itself, the heavy current is flowing right at that moment between these two contacts. So since it is very heavy current and it is able to ionize the surrounding environment, whatever the medium, so they will get ionized and they will give the path for the conduction for the long term. So and again there is a chance of restriking this arc if they exist there itself. So these ions which were caused for this delayed delay and cause for the arc. Again, they may restrike. The voltage is more, and dielectric strength breaks. So dielectric strength breaks if the power is more. So the oil, it will. So in the oil, the hydrogen will create the turbulence, and it will disturb this matter, which is the cause for this restriking. So in the case of the SF6, it is able to absorb the electrons, and also dielectric strength is very, very high. So the restriking, the chance for restriking will be very, very less. And even this is not enough at some times at very, very high faults. So that's why we are going for the another type of the circuit breaker, that is the vacuum circuit breaker. So in the name itself it is there. It is very, very clear that the medium, the arc extinguishing medium, is vacuum. So you may get the doubt. So if the vacuum itself is the medium, so there is, why the chance of restriking the arc again exists? Vacuum means the meaning is nothing is there. So air means air is there. So even though its dielectric strength is high, but the fault is very, very high current. So okay, again if you come to the oil, also hydrogen more than the air again. So again SF6 more than the air, 3 times more than the air. So even those cases we are having the chance for restriking and for the delay of the arc quenching, because of some kind of medium is existing there. But if you are saying the vacuum means there is no medium, practically there is no medium at all. But how? So that's I will explain. So here the medium is the vacuum, and it is best among the all breakers because it is having the highest arc extinguishing. It is best arc extinguishing because vacuum provides the highest insulation strength. Then if there is no medium at all, if the vacuum means nothing, then how? It has to stop immediately, and the chance of restriking should be 0. But even here also it is occurring. So one thing we have to keep in mind, that the faults are of very high power, high current, and here the arc is formed due to the ionization of the metal vapors of the contact. The fault is such a, the fault current will be in such a high level that the metals, the contacts, we are using the contacts are made up of metals, they will generate the vapor, that also ionized vapor, because of that power or the fault. So these metal vapor, ionized metal vapor will cause the arc here. So imagine how much high faults we are having in our power system. So then also, so theoretically we thought that if no medium at all is there, if we are able to create a vacuum, there is no chance of striking an arc. But practically, in the vacuum also, the arc is existing. Arc is striking. So then why we have to go for the vacuum? So even though we are unable to stop it, but even still this is the best. Because even though arc is struck here, it extinguishes very fast, very quickly. Because the vapor generally condenses fast. So even still, so practically it's a failure to create a zero arc. But still it is a success because very, very fastly we are able to extinguish the arc. And also this also contains moving contact and fixed contact as the other circuit breakers. The outer insulating body is made of glass or ceramic. Either it can be made with the glass or the ceramic. So this is the diagram. So the insulating vessel, the arc shield, and the contacts. So there will be arcing range and a movable member and the fixed member or contact. Similar, almost all similar. Design may be somewhat different because we have to create the vacuum. So what are the advantages? This is having highest advantage over the remaining previous things. So because simple thing, it is the vacuum circuit breaker. So there is no fire hazards. So fire hazards cannot exist. And it is compact. It is compact. So it is very reliable and it has very long life. So no gas is generated. No gas is generated because it is vacuum. So zero hazard, long life, compact, reliable, and no gas. And also it requires very less maintenance and it can interrupt or it can extinguish any fault current. That may be how much high fault current it may be. It can interrupt because it is vacuum. Even it can withstand the lightning strokes, lightning strikes. So low arc energy is released. Generally during the arc extinguishing, the energy is. So lowest arc energy is released. Okay. So these are the advantages. So zero hazards, reliable, highly reliable, very long life, no gas, compact, less maintenance, It can end any current. It can extinguish any current, fault current. It can withstand the lightning strikes, and low energy is released. So these are the advantages of the vacuum circuit breaker. So then we'll see actual theory behind this arc interruption theory. So there are mainly two types of theories here, that is Selfian theory and Cassis theory. Selfian theory and Cassis theory. So today we will discuss about the Selfian theory. So this theory is having two other names other than the Selfian, as the recovery theory or voltage race theory. So recovery theory or voltage race theory. So this theory describes the arc interruption theory as the arc interruption as the race between the dielectric strength and the restriking voltage. So it is the race between the dielectric strength. So generally any medium will have the, so we need a bad conductor. So dielectric strength. Okay. So we have tried with the air, we have tried with the oil, we have tried with the vacuum, we have tried with the SF6. Okay. So the more dielectric strength we have, the more advantage we have. But so again, when the process goes on, the restriking voltage will occur. So which is stronger? So this theory is telling that, so this Selfian theory or recovery rate theory or voltage race theory, this theory is proposing that so there are two types. From theory we can develop the practical, from practical we can conclude a theory. So here from practical thing we are concluding theory. Okay. That might be the reason for this thing which is occurring practically. If we are developing, so if you are developing certain thing from a theory, that is sure, the theory is 100% correct. If you are developing a theory from the practical, we cannot be 100% sure. Probably it comes to near. In all the cases, in some cases only it may be exactly right. Okay, this is proposing that it is a race between, why the arc is again happening? It is a race between the restriking voltage and the dielectric strength. So if the once the arc interaction happens, the arc happen means that itself, the meaning is the dielectric strength has broken. The dielectric strength of certain of that medium, whatever it may be, has broken by the fault. So the arc exists, and we have made the arrangement such that it extinguishes as quickly as possible by different mechanisms, by different mediums. But If after the arc has extinguished, the dielectric strength has to recover itself as fast as possible when compared to the restaking voltage. So if it is slow, then the arc exists. Arc again strikes. If it is faster than the restaking voltage, the arc will not occur again. It is so simple. It is very simple. So one person got a fever in certain rainy season. So after the treatment, he has to recover as early as possible. Again, if he goes to the rain, so if the stamina in him, the natural stamina in him has not recovered as fast, again there is again the fault, again the fever occurs. So the natural immunity has to build up after the fever. If it is slow than the fever conditions, again the fever will come. So here also, if the dielectric strength is slow when compared to the restaking voltage, that's what the chance of occurring arc will strike again. The arc will strike again. Okay. So after every current zero, some residual ionized gas will be there, causing the arc to strike again. So it will support to arc to restrike. So according to this theory, the rate at which positive ion electrons combine. So the positive ions and electrons, so if they combine very fastly, so that medium will recover the dielectric strength, and if it is slow, combine from neutral molecules is compared with the rate of rising of restaking voltage. So if the restaking voltage is faster than this combination, the arc will strike again. If it is combination, the positive ions and electrons combination is faster than this restaking voltage, the arc will not strike again. So the combination means here positive ions and electrons means it is forming the neutral. So that means the dielectric strength is getting recovered. So it has to recover very fast than the restaking voltage. So the rate of recovery of dielectric strength is compared with the rate of rising of restaking voltage. So if the restaking voltage rises rapidly than the dielectric strength, what happens? The arc strikes again. If the dielectric strength rises rapidly than the restaking voltage, what happens? The arc will not strike again. So with this diagram it is clear. So A is the case. Dielectric strength is more. Dielectric strength is, so this is the case. So dielectric strength is faster than the restaking voltage. So that means it has won in the race of against the restaking voltage. So arc will not occur. This is the case B. the arc is faster, the restaking voltage is faster and dielectric strength is slow. That means the arc has struck again. So, okay. So today we have seen about the vacuum circuit breaker. So it is the last highest possibility. It is the best possibility as far as today to minimize the restriking of the arc or to extinguish the arc as quickly as possible. So vacuum means the medium is vacuum. There should not be any medium chance of existing arc, but still the arc is existing because of the metal, ionized metal vapor. So even then this is best because the vapor gets condensed very fastly. So the arc is also extinguished very quickly. So it also contains a moving and fixed contact and outer insulating bodies made up of glass or ceramic. So this is the diagram. So arc shield, insulating vessel, fixed and movable contacts. So the advantage is it is nil hazards, very long life, compact, very reliable, and no gas, and very less maintenance. It can interrupt any fault or it can extinguish any fault. It withstands the lightning striking and very low arc energy is released. And the arc interruption theory, the first thing we have discussed, that is Selpian's theory, which is also called as the voltage race theory or recovery rate theory. So this theory describes, this is the race between the restriking voltage and the dielectric strength. So after the zero current, still some residual ionized gas exists, and this will be the cause for, this will support the arc if the necessary conditions come again. So whenever after the arc extinction, so if the positive ions and the electrons combine very fastly, which increases the dielectric strength of that medium. So if restriking voltage is faster than the dielectric recovery of the dielectric strength, so arc exists. Arc will strike again. And if the dielectric strength is recovering more faster than the restriking voltage, the arc will not strike again. So that is described in this. The point A is, this is where the dielectric strength is faster than the restriking voltage. In the case A, the arc will not strike again. And this is the case B, where restriking voltage is faster than the dielectric strength. So again the arc will strike. So this is a, so what is the drawback? So this drawbacks in this theory. So drawbacks in this theory assumes that the dielectric strength and restriking voltage are comparable things, which is not correct. And also they are not considering the energy relations in the arc extinction. The arcing phase is not covered. Here the arcing phase is not covered. So these are the drawbacks. That means they are comparing these two quantities as the comparable quantities, which is not right. Which is not exactly right. And they are not considering the energy relations. And also they are not covering the arcing phase. So this theory does not satisfy. So we are going for the second theory, which is more relative. Okay, that we will see in the next video. Thank you for listening. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.